Welcome back to the channel. In the previous video, we looked at the construction of a loci, and in today's video, we will. So on the screen, it shows the given triangle that we'll be working with today. So the first step would be to watch the previous video entitled How to Construct a Triangle Given the Altitude and the two base angles. I may link it up in the top of the screen if it's there now. Then we're going to draw a square which is equal in area to the triangle. So today's topic is the equivalent areas, and specifically today we are drawing a square that is equal in area to a given triangle. So you need to visit the other video that would show you the construction of a triangle given the altitude and the two base angles. All right. So what we have a perpendicular here that we dropped from the top of the triangle to intersect the base. All right. So here is a triangle that was asked for to be drawn above there with the altitude of 80 millimeters and the two base angles of 45 degrees and 60 degrees. Okay. Should be 45 degrees and 60 degrees. Yes. So this is the triangle. All right. What I proceeded to do was to construct a rectangle which is equal in area to this triangle. Okay. And this is it right here. So this is a rectangle. So I want a rectangle equal in area to the given triangle. All right. So let me. Okay. So after we drew the triangle, which is this, then we converted the triangle. We drew a rectangle equal in area to the triangle. See that? So this rectangle is equal in area to the triangle. Okay? So this rectangle below here is equal in area to this triangle. All right. Now the next step, remember, the purpose is to draw a square equal in area to a given triangle. But the first step is to draw a rectangle equal in area to the triangle. So if you look at it, this area here, what is common to both the triangle and the rectangle is this trapezium under here, yes? So if you look at it, this area is equal to this triangle, and this triangle is equal to this triangle. So that is how we are sure that this rectangle is equal in area to the given triangle. All right, so what we're going to do now, we're going to convert the rectangle. We're going to draw a square now that is equal in area to the rectangle. All right, good. All right, so we're now going to move on with the construction to get the square equal in area to this rectangle. So the first step is to draw a semicircle, an arc equal to the height here, which I did here. Then the next thing we're going to do, we're going to bisect this point, the end of the rectangle, with the semicircle that intersected the baseline construction over here. All right? All right, so after we drew this arc coming down to intersect this construction line going to the right of the rectangle, we bisected this point with the other end of the rectangle, right? The base of the rectangle. And so we scribe an arc from this point, we scribe an arc from this point, and where the intersect, we're going to draw the line now. So line, enter, right? The semicircle drawn from this bisector that intersect the baseline for the rectangle will be the center for the semicircle. The radius, this will be the center, and the radius will be this corner of the rectangle. So let's do that. As I indicated, we're the bisector of this point and the left-hand base of the rectangle, where the bisector intersect this bisector, where this bisector intersect this baseline. This is the center for the radius of this construction semicircle. Where this construction semicircle intersects this right angle that was drawn previously to get the side of the rectangle, that would be the length of the one side of the square, right? So you put the compass down here, down by the right hand base of the rectangle, and you draw a semicircle, right? To transfer this measurement of the square to the other side, right? Good. All right, so arcs drawn from where this arc intersect this baseline right here, right? And here we draw two arcs equal to the length of the side of the square, right? So this length that we got here from there to there, we open our compass and we scribe two arcs from this point and this point to give us this intersection, right? Where the two arcs intersect, that would be the required square, all right? All right, so we're gonna draw, so where these two arcs intersect, that would be the center, the corner, the next side for the square. So where this semicircle intersected this perpendicular line that was used to draw the rectangle, where this arc intersect, that will be the radius. And we'll put the compass at this point and we mark an arc, right? Then from this point and this point, mark two arcs equal to the length of the side, right? So we're gonna draw this square now. So from there to there to there to there to there, enter. So this would be the square that is equal in area to the rectangle and the triangle that was given. So this drawing brings us to the end of today's video, construction of a triangle and equivalent area. So having constructed the square, we are definitely at the end of today's video. So thanks for watching. In the next video, I'll be looking at the intersection of solids. It will be two pipes that meet at right angle, and we need to produce the line of intersection that is formed between the two cylinders that will meet at 90 degrees. So see you in the next video. Let me know your thoughts about the video. All right? All right. See you then. Bye.